Pact, and our project is the maze attack. If you look right here, you can see our beautiful maze. This little red guy here, it's 3 by 3 pixels, is the player. You can move him using these buttons here. This is right, left, up and down. If you look right there, he's moving real good. And if you look here, this timer is a real-time timer. It basically tells you how long you took to finish the maze. Obviously, your goal is to go from the start of the maze to the end of the maze. And this right here is the reset button that resets the timer and resets the maze itself. So, this maze can be just a little bit challenging. I've done it so many times, it shouldn't take me long. Let me give you a quick demonstration. So, took slightly longer than expected. It's okay, everybody makes mistakes. Anyways, now, if you look here, if I go down, I should win. So, please look at the timer first. It's working perfectly, keeping my score. So if I go down, the screen goes green, signaling that I won. If you look at the timer now, the timer stopped. So this is the score I got. I did it in a minute, 12 seconds. Good enough, I guess. So, now my colleague is gonna explain how we made the maze. Enjoy.
Like Omar said, we are doing the maze project. So how do we actually generate the maze that will be displayed on the screen? So we got this online generator, maze generator, that takes in the dimensions of the maze and outputs the maze with a solution. And we take this image and then we compress it to become the same size as pixels as we want. Then we take this image and then we plug it into this Java code that checks every pixel. If it's white, then it's not a wall. If it's anything but white, then it is a wall. So actually, let me run the code. As you can see, it displays the dimensions, which is 200 by 112. And this is the look of the Verilog syntax. This maze has 22,400 pixels. And now we're going to my friend, my next colleague.
So now I'll be talking about how we use the output of the Java code my colleague made in the maze module itself. So the output of the Java code is a bunch of zeros and ones. So we make a register that is 22,400 in size and put the pixels in it pixel by pixel. Where zeros represent the places where the player can move and 1 represents the walls in the maze. Then we keep track of the player moves like this. These are the movements of the player. We keep track of these movements by keeping track of the top left corner of the player. The player is a 3 by 3 square. We keep track of this, and if we move right, we move that single pixel 1 to the right, and if we move left, we subtract 1. If we move up, we subtract 200 because the maze has 200 in rows, and if we move down, we add 200 to that pixel. Next, my next colleague will be talking about how the hardware is connected to the FPGA and how the buttons work.
Friends previously explained, we used 4 buttons in order to control the movement of the player: right, left, up, and down. These buttons were used as active high buttons. In order to connect them in a suitable way, we used the Samsung charger as an input power source, connecting it to a voltage regulator, taking this current through and dividing the voltage of it across 3 resistors, taking the value of the second resistor as an input to the button circuit, then connecting the ground of this circuit to the common ground of the power source circuit. After that, we used the output of the button and connected it as an input for the FPGA GPIO. This output was regulated through a pull-down resistor, which functions as if you didn't press the button, the voltage will remain at 0. Once you press the button, the circuit closes, allowing the current to pass through the pull-down resistor, yielding a value of 3 voltage to the FPGA GPIO.
So how does the screen work? The screen is connected to the FPGA using a VGA connection, It produces a 640 by 480 image. But for our project, we opted to use a smaller resolution for the maze, 200 by 112. So basically, there are two addresses that are used to produce the image. One that goes through the whole screen, and one that starts when we enter the boundaries of the maze. Once we're inside the boundaries of the maze, the address is checks whether this pixel is a player, colors it red. If it's 0, which represents an empty space, and it's colored blue. If it's 1, which represents a wall and produces a white pixel.